Hey guys, it's Ethan from Zimmer Labs, and this is just a quick video to revisit this PC that I built for Michael. I built it for him a couple months back, shipped it out to him, and I guess he ran into some blue screen of death issues. So I asked him to send it back to me in order to take a look at it and see if I could figure out what was causing the problem, because when I had it, it was running just great. So basically, figure I'll take you through the build really quickly. This is a NZXT H510 Elite case, Tai Chi Z390 motherboard. It's got a Noctua NHD14 cooler with a Noctua fan, 64 gigs of G-Skill Samsung B-Die RAM, and 3 M.2 solid-state hard drives. The processor is a Intel i9-9900KS Special Edition, and because you can't see the processor, here it is. It is delidded, and this is a direct die frame so that it can be direct die cooled by the Noctua cooler. So this shiny part right in the middle is the actual die of the processor, cleaned and polished, and then this frame holds it in place on the motherboard. Then the Noctua cooler bolts onto this and this screw post here and sinks right to this die to cool it off using the giant aluminum heatsink and fan. Now, my thought is that when it initially got shipped to Michael, I double boxed it to be extra careful, but it did take a bump. So it's possible that the seal on the heatsink on the CPU cooler might have got jostled a little bit and broken the seal on the cooler to the CPU, which would cause it to not work quite as effectively as it should, which could cause blue screen of death issues if you're overclocking. So that's the first thing I did, was remount the heatsink, reapplied the thermal paste, and then I just went through everything quickly and just, double and triple checked everything to make sure it was working correctly. And as far as I could tell, it's working exactly as it should. So I'm going to do is quickly switch over from my computer to Michael's computer, and then we'll boot it up and see how it's doing. Alright. Alright, so this is now connected to Michael's computer, and from being completely off, start it up and see how it performs. And that quickly, we're already booted to Windows, which is great. It's pretty much exactly what you want to happen right there. You want to have a nice fast boot. So that was about 25 seconds maybe. I'm going to go to System Information Viewer, start it up, and this shows us that we are running overclocked at 5 gigahertz on all cores, with the temperature right around 32-ish on average, 3.6 gigahertz speed on the RAM, and 1.35 volts. So nice and cool and stable on that overclock, which is exactly what you want to happen. Now what I'm going to do is I'm going to jump on the network. I'm I'm going to pull a large video file off my server and copy it over to here. Let's see, let's do this one. This is a 14 gig file, so a good size. I'll paste it over here onto the storage drive. So you can see we're getting transfer speeds of over a gig a second, just about 1.1 gigs per second transfer speeds, which are outrageous, really good speeds. I'm going to copy this over to the other M.2 storage drive. And here we're getting transfer speeds of right around 3 gigs per second, which is totally outstanding. Like, couldn't ask for better transfer speeds than that. I'm going to open up Shotcut, my preferred video editing software. And I'm going to drop that file in that we just copied over from the server. And then I'm going to render it and export it in YouTube standard settings. And we've got it started. Processor's running at 5 gigs on all cores. Temps are still nice and low. 41 degrees, 45 degrees, 50 degrees, 60 degrees, 46 degrees, 39 degrees. It's 30% CPU usage on all cores while it does this transcoding or rendering. According to the timer over here, it says it's going to take about 8 minutes to finish. It's already 5% done. Computer's having absolutely no problems doing this whatsoever. While it's doing that, I'm going to jump on the web. Let's see, let's take a look at this hard drive. Computer obviously has no problems multitasking while it's transcoding, rendering a 14 gig video file, so that's a good sign. Temps are nice and cool still. Voltage is right where you want it to be still. Power is, it's only running 85-ish on average, 85 watts, which is terrific. Actually, no, I lied. Current wattage is right around 100 watts. Maximum, it hit 148. But it's alternating between 67 and 140. So I'd say on average it's around 80 or 90 watts while it's running overclocked on all cores, which is great. You really can't shoot for anything more than that. And again, it's totally stable. We're at 20% on the transcode now, so about 6.5, 7 minutes more until it's finished. Let's see. That's about it, really. I mean, other than that, computer looks good and is performing exactly as you'd want it to. Handling a good stress test with aplomb and with ease. What I'm going to do now is I'm going to stop this video render. We're up to 30%. I'm going to stop it. I'm going to close this. I'll save the project. And I'm going to restart to the BIOS. what I'm going to do is I'm going to turn the overclock up to 5.3 gigahertz on all cores. And then we'll rerun that same video editing. So there we go. We've got i9-9900KS, 64 gigs of G.Skill 3600 RAM. Let's turn the overclock up to 53. RAM is good. Just make sure that the fans, the fan settings are all good. Set to aggressive. And we'll reboot. I should pull Windows up no problem and run stably at 5.3 gigahertz. So that's what this CPU was binned at as far as all my testing. Alright, so we'll pull up System Information Viewer again. Now we're at 5.3 gigahertz on all cores. Still nice low temperatures, 28 degrees, 30 degrees, 1.07 volts. That's terrific. You can't ask for better than that. We'll open up this shortcut program and pull that same project that we were just doing up again. And let's see. I'm going to export the file. And it's officially rendering and transcoding again right now at 5.3 gigahertz on all cores. Temperature is again nice and cool and stable. 50 degrees or so, 41 degrees, 44, 43, 47, 71 is a peak, 63, 49, 45, 61, 56, 48. So as you can see, it's averaging right around 50 something degrees under stress, with peaks as high as 75 degrees and as low as 40. So, nice and stable. Still only 33% CPU usage. Still a nice low 1.29, 1.28 volts. Wattage is still between 72 and 150. So, averaging 59 watts. We're averaging around 100 watts. We're averaging around 1.3 volts. We're averaging around 55 degrees. And that's under stress, under load. We're already at 11% done, so this is rendering and transcoding even faster at 5.3 gigahertz, which obviously is what you would expect. But as you guys can see, Michael, hopefully this gives you some peace of mind. I'm not sure exactly what caused the blue screen of death issues you were experiencing, but all I can say is it's rock solid and stable and doing exactly what it should do. I would suggest not installing a whole bunch of additional random software that's, overclocking related, because that kind of thing can mess it up. All you need for overclocking is the settings that are available in your BIOS, and anything else is just going to get in the way and potentially cause problems. But everything is running at its full overclock speed, memory, CPU, and it looks terrific. Up to 24% now on the transcode and the rendering, still just rock solid. So, as far as I can tell, this computer is performing exactly as it should. 100% stone cold stable, and couldn't really ask for anything more. So it's all set. I can pack it up and send it back to you whenever you are ready. Thank you guys as always for watching. Hopefully this was somewhat informative, at least on the overclocking side for you guys. And stay tuned for actual lightsaber videos coming up. I've had to take a bit of a break to handle some workshop related updates, but most of those are finished and it'll be back to work in the near future.